Okay, beginning next part, part 3. So, let's add these two together. 3 electrons here, 3 electrons here, we'll cancel those out. That's good. Anything else we can cancel? Hydrogens. So we've got 3 on this side and 4 on this side. Let's get rid of those 3. Let's get rid of the number 4, so we've only got 1 hydrogen here. Anything else? I think we're stuck with everything else, aren't we? All right. So we have gold, Au, and we have 4 hydrochloric acid, and we have nitric acid. And that's everything on this side, isn't it? We got rid of the electrons, we got rid of the hydrogens. So on the other side, we have AuCl4 minus, so that's there, and we have nitrogen monoxide, that's there, and we have 2 H2O, and we have an H+. Okay? Okay. Now ideally we should go in and add phase designations here where appropriate. The acids of course are in solution, but the gold is a solid. This is a liquid, and this is a gas. Okay. All right. Are we balanced by charge on both sides? Total charge on the left is 0 because there are no ions. Total charge on the right, we have a -1 and a +1. They balance out for 0. Good sign. Let's check atoms. So we have a gold here, that's good. We have 4 chlorines here, 4 chlorines there, that's good. We have 4 hydrogens, and
You have another hydrogen.
oh, we have 5 hydrogens, don't we? That's good. So we have 4 hydrogens there and 1 more there, so that's 5. We have a nitrogen here and a nitrogen there, that's good. And we have 3 oxygens, and we have 1, 2, 3 oxygens there. We are set. Okay. So, what is the hardest part of this process then?
Remembering all the steps.
Remembering the steps and doing them in the right order. Okay? So, first thing you should do, if it's not given to you, get a skeleton equation. Just showing, what is there. From there, use the rules that you learned to determine oxidation states. And just as a review, what are those rules for determining oxidation states?
Pure element is 0.
Pure element is always 0.
Fluorine is
Fluorine is always -1.
Monatomic element is the same as its charge.
Monatomic ions are the same as their charge.
Hydrogens plus
Hydrogen is +1 in any covalent compound.
and then
Oxygen is -2 except for, if it's peroxide, then it's -1. Everything else you can deduce after doing all that. Okay? All right. So,
Why does it take nitric acid with hydrochloric acid to dissolve gold?
we're going to learn that in chapter 17. It turns out that the stoichiometry alone is not enough to make it happen. There are some electrochemical things going on.
Did I
And
ask where stoichiometry plays in this?
we just did it.
This is the stoichiometry of that.
Yeah, this is a long roundabout way of a stoichiometry problem. The reason we do redox this way is because realistically there's no way we could balance it if we don't.
It's easier this
But ultimately this is just a stoichiometry problem. We use some different steps to accomplish it, but the end result is the same. Get the same number of atoms on both sides and get the same total charge on both sides. Yeah,
Is nitric acid a controlled substance?
not to my knowledge.
So we can make this stuff.
You could make
Royal water.
royal water?
Problem would be the gold there.
Sure. Yeah, getting the gold is going to be the hard part of this equation.
Wedding rings.
No,
Just like demonstrate.
I just got it finished.
My dad had a gold wedding ring, and he left it in his scrubs in his first year of marriage. My mom's lost two
Ooh, that's a
rings.
problem. That is a
My dad
problem.
just gave up. My dad's
My
lost.
mom lost her wedding ring at Disneyland.
That's where my mom lost her first one.
Her first one.
Yeah, she's lost two.
Oh my.
My dad's lost like 5 or 7.
Which leads me to the question, why does she keep buying them for him?
No, he buys his own now. He buys
Oh,
private ones.
okay, well, okay, there we
He
go.
buys like a plastic
All right. All right. We do have one more redox problem I want to show you. Okay? It's not scary, but it's different.
Basic is.
Balance the following chemical reaction that takes place in a basic solution. Okay? Now, here's the good news. We're going to treat this just like it were an acidic solution, up until the very end. You'll see what I mean. Okay, so tell me what we've got here.
Permanganate
Permanganate ion
and sulfide.
and sulfide ion.
Manganese sulfide.
Close.
Manganese 2.
Manganese 2 sulfide
And sulfur.
and sulfur. Okay? Good. So, what is going on here? Well, let's look at it. Okay? So, first thing we got to do is identify what's being oxidized, what's being reduced. We need oxidation states to do that. Manganese here has an oxidation state of, remember it, we just saw it,
7.
+7.
Why doesn't it just depend on the oxygen?
It does. But we actually saw this ion a couple of slides ago, and it was +7.
Not so long ago.
Yeah, I know.
But there's
-8, the total charge is -1. So this has to be a +7. Okay? Oxygen is -2, there's 4 of them, that makes a -8. If the overall charge is -1, there has to be a +7 charge there somewhere to offset it. That's where it is. What about sulfur? Or technically this isn't sulfur, this is sulfide. -2. Okay, what about this? Sulfide is still -2. What about this? +2. And this sulfur? 0, because it's a pure element. Okay, so oxidation. What is being oxidized here?
I forget what that. What was that?
Sulfide.
Sulfide ion is being oxidized to sulfur. S2 plus, yeah, like that's going to happen. 2 minus, being oxidized to sulfur. Okay? The reduction that's taking place is permanganate being reduced to, wow, manganese sulfide.